Hi, I'm taking Paul McWhorter's Python 3D graphics using vPython class, and we're on tutorial number 12, understanding axis and parameters. A lot of trig involved, and I did the homework and didn't feel it rated a video, so I didn't do that, but I decided to challenge myself, and I use trig sometimes in my work life and everything. Cosines and sines aren't that big a deal, but I thought about doing a challenge of the latitude and longitude of a globe. So that's, I guess, considered spherical trig or 3D trig. I haven't done that since high school, so I had to look a while to find out how all that works. So I found a couple articles to read, but on the coding side of it, this was the one that brought it out the best for me. Is that any angle and two angles in 3D space, you can plot them using these formulas here to fill in your axis points on your line or your position of any object in space. So I took that as a starting point and played around with it for a couple hours, and finally got it so we're able to trace out the latitude and longitude of the Earth or a sphere. And I did it in 10-degree increments. Let's go to the code. So basically we started with what we've been doing with Paul, just doing our X, Y, and Z arrows on the screen. And one thing I did do is that I wanted to use trails to draw this, and you can't do trails with arrows. So at the end of the arrow, I put a small sphere, same color as the arrow, and I set the trails to be true and make trails true and trail type points, and these other trail things so that we get nice little dots on our screen when we do the follows the trail. Basically, using the 3D trig to draw the longitude, you just need to work through two different sets of a nested loop. If you're drawing circles, you only need, there's 360 degrees of longitude. So if we want to do every 10 degrees, that'd be 36. But since we're drawing a circle, you only need 18 circles. So 18 increments to get that. I had to learn a little bit about this lens space. This false means that you're not taking the last one into account when you're doing your calculations. If you leave this off or leave it as true, you don't get 18 increments. You get 18 lines, but not 18 spaces. We are looking for 18 spaces or 36 spaces, not lines. So had to leave that as false. So that was a little bit of a learning curve on that. And then this, we're just looping around in our the other direction. So we're using that. So we're getting longitude, angle, which is every 10 degrees, and then my angle, we're just doing 1,000 per revolution on that. So 1,000 dots along that. We're setting our rate to, I think I got to set 1,000, so it doesn't take too long to do it. Like I said, we got the arrow is just showing, but to get our trails, we're just putting a point. So these are just copies of each other. So if you go back to that one that we had up there, we actually, so it looks right on our thing, we're using our Y axis is really our Y-axis drawing, our X, Y, and Z. Y is up, and more traditional coordinate plane Z is up. Not for math, but for like industry and drawing, Z is up. In CAD programs, Z is always up. So I had to turn my thinking around so that I could have changed the camera angle, but I decided to keep the camera angle as it was and just work with figuring that Y was up. So what basically just have to do our math, the 3D math on that. And then on the latitude, since we're going from 90 north to 0 and then 90 south, that's actually 19 circles. Of course, 90 up and 90 north is going to be circle's going to be all in the same spot, but it still does 1,000 iterations of that 0. But I just wanted to start and finish at the same place. So I just, so we got 19. And this one actually has to be true because you do want 19 increments through that 19 circles. Like I said, basically just running through and then working through the math for that. Had to sit and think about it, and actually didn't get it the first time for sure. So I had to go through it about 2 or 3 times. I was drawing the latitude in the wrong place. So I had to work on that a couple times. But anyhow, after I got it done, it worked out pretty good. So I'll just show it off now. Like I said, it's moving pretty fast. So we'll show the top of it. So we're drawing a circle, moving 10 degrees, drawing another one. Like I said, you can see that got the right amount of, since we went to 90 was for the axis. And then it's going to draw our circles for latitude every 10 degrees. And again, you can see that when we get up to 90, or to 0 degrees latitude, it did it again. Got it right on the dot. And we finished at 90 south latitude. So that's all I really wanted to show. Dusted off some math skills I haven't used since high school. So that was pretty interesting. I haven't, like I say, I use trig sometimes in my real life, not day to day, but once or twice a year, I have to use trig around the farm to figure things out. But never had to use 3D trig or spherical trig to do that. So that was interesting. Anyhow, thanks, Paul, for all you do, and just want to show off and see. Hope to see more lessons. Bye.